Hello everyone, this is me Garima Singh. I hope you all are doing well. Today we will study about the topic that is particle physics. It's that branch of physics where the standard model identify its model of physics. So it's basically identify elementary particles into quarks, lepton, bosons. That is the standard model of physics. यानी कि जो standard model of physics है वो जो एलिमेंट्री पार्टिकल्स हैं उनको आइडेंटिफाई करते हैं. एलिमेंट्री पार्टिकल्स लाइक क्वार्क, lepton, boson. Now the second I'll talk about the next is what is antimatter. So as you know that every matter has an antimatter, यानी कि जो भी मैटर होता है उसका एक एंटीमैटर ज़रूर होता है. इसमें क्या होता रहता है कि जो सेम उनका मास एंड वॉल्यूम सेम होता है, लेकिन जो सिर्फ एक जो डिफरेंस है, डिफरेंस वही रहता है इनहेरेंट चार्ज. So antimatter, as you know that every matter has an antimatter. Every matter has an antimatter. The similarities between matter and antimatter is their mass and volume, and the difference is being their inherent charge. So that is antimatter. Antimatter has an opposite charge when compared to its matter. जो भी मैटर का चार्ज होता है एंटी मैटर, ऑब्वियसली नेम एंटी, इट्स मीन्स ऑपोजिट ऑफ इट्स चार्ज. जैसे कि प्रोटॉन के एंटी मैटर को एंटी प्रोटॉन कहते हैं. प्रोटॉन का एंटी मैटर हो गया एंटी प्रोटॉन. वैसे ही अब वी कैन टुक द एंटी मैटर ऑफ इलेक्ट्रॉन. सो जो इलेक्ट्रॉन का होगा उसका है पॉइस्ट्रॉन. तो मैंने वही डिस्कस किया एंटी मैटर का. लाइक एवरी मैटर का एक एंटी मैटर होता है जिनका मैटर और एंटी मैटर का जो मास एंड वॉल्यूम वो सेम होता है. डिफरेंस होता है बेसिकली देयर इनहेरेंट चार्ज. लाइक एग्जांपल प्रोटॉन का एंटी प्रोटॉन एंड इलेक्ट्रॉन का पॉजिट्रॉन. नाउ वी विल टॉक अबाउट क्वार्क्स विच आई हैव रिटन हियर, द एलिमेंट्री पार्टिकल्स. सो quarks are, these are elementary particles, like I said, the basic one. They join to form hadrons such as proton and neutron, which are component of the nucleus of atom. So इसका भी एक एंटी क्वार्क होता है. यहाँ पे 6 प्रिंसिपल क्वार्क होते हैं. 6 प्रिंसिपल क्वार्क होंगे और देन 6 एंटी क्वार्क होंगे. लाइक क्वार्क क्या मैंने बोला, ये एलिमेंट्री पार्टिकल है जो कि स्टैंडर्ड मॉडल ऑफ फिजिक्स में आपको मिलेगा. ये ऑब्वियसली it's joined to form hadrons such as proton, neutron, which are component of nucleus of atom. Of course nucleus of atom के ये component होते हैं proton, neutron. यहाँ पे आपको 6 principal quark मिलेंगे तो 6 principal anti quark मिलेंगे. Quark and anti quark are the only 2 fundamental particles जो कि interact करते हैं through all 4 fundamental forces of physics. ये interact करते हैं फंडामेंटल फोर्सेस ऑफ फिज़िक्स. ये तो आपको पता ही होगा फंडामेंटल फोर्सेस ऑफ फिज़िक्स, जैसे कि ग्रेविटेशनल, इलेक्ट्रोमैग्नेटिज्म, द स्ट्रॉन्ग इंट्रैक्शन एंड द वीक इंट्रैक्शन. लाइक सो 4 fundamental, okay, I have to write here also. So it's gravitation, electromagnetism, the strong interaction and weak interaction. So a quark exhibit confinement, which means that quark are not observed independently but always in a combination. जो quark होता है आप उनको independently observe नहीं कर सकते, but आप combination में ही करोगे with the other quarks. This makes basically determining the properties like obviously it makes it impossible to measure directly their mass, spin and parity because they are work in combination. Now the next here which we have written leptons. I'm gonna use more English because I don't know what I would say in Hindi. Those words though I will make use more of English. लेप्टॉन्स जैसे कि क्वार्क होते हैं वैसे लेप्टॉन्स होते हैं. इनके भी 6 टाइप होते हैं. I mean like quark, leptons, 2 are of 6 types. However, they do not have any fractional charge. इनका कोई fractional charge नहीं होता. तो I've put cross here. लेप्टॉन्स को आप बोल सकते हो जैसे इलेक्ट्रॉन, म्यून. नाउ द नेक्स्ट इज फेर्मियन. दीज आर basically particles which have a half integer spin and therefore constrained by the Pauli exclusion principle. Constrained by the Pauli exclusion principle. So, and particles with integer half spin are called boson. We will discuss about in detail. Fermion include electron, proton, neutron as well as quark and lepton also. Now what this is, the fermion nature of electron also govern the behavior of electrons in a metal, where at low temperature, like low temperatures, all the low energy states are filled up to a level where they are called Fermi energy. Now we'll discuss about boson. So ये इट इज़ अ बेसिकली ये कलेक्टिव नेम है जो उन पार्टिकल्स को दिया गया है, दोज हु कैरी फोर्स. सो इट्स अ कलेक्टिव नेम given to particles that carry forces. Particles that carry forces, it has been named after. So यहाँ पे ये ध्यान रखना है कि it has been named after Indian scientist Satyendranath Bose. Satyendranath Bose. Yeah, this is the very proud thing as well as a keep in mind kind of thing. So it is named after Indian scientist Satyendranath Bose. Gravity as a force of nature is yet not accepted by the standard model because due to failure to discover it boson. But you see that strong nuclear force is the strongest known force while gravity is the weakest. Yeah, that is, nuclear force is the strongest one and gravity is the weakest one. Now we will discuss about God particles, which you have heard in news. The next is, these are very interesting topical particle physics. So the next is God particle. I'm gonna use more English. So God particle, Peter Higgs suggested that particle did not have mass just after Big Bang. Big Bang के बाद पीटर हिग्स ने बोला कि जो पार्टिकल्स होते हैं उनमें मास नहीं होता, because as the universe cooled and temperature fell below the critical point, an invisible force field got formed, जिसको हम हिग्स फील्ड बोलते हैं. सो आई शुड रोट हेयर. पीटर हिग्स ने बोला कि जो पार्टिकल्स होते हैं उनका मास नहीं होता. ये बात उन्होंने बोली लाइक बिग बैंग के बाद, बिग बैंग थ्योरी के बाद, जो भी बिग बैंग थ्योरी थी जिससे हमारा यूनिवर्स फॉर्म होता है. तो उन्होंने बोला था कि जो पार्टिकल होते हैं उसका मास नहीं होता जस्ट आफ्टर बिग बैंग. सो जो यूनिवर्स होता है वो कूल्ड हो जाता है. कूल मीन्स उसका टेम्परेचर कूल्ड हो गया, तो उसका जो टेम्प है वो फॉल हो गया, एक इतने क्रिटिकल पॉइंट तक हो गया कि वहाँ पे आपको एक इनविजिबल फोर्स दिखेगा. उसको इन्होंने नेम दिया हिग्स फोर्स, हिग्स फील्ड. देन द एसोसिएटेड पार्टिकल विथ हिग्स फील्ड, जो इस फील्ड से एसोसिएटेड पार्टिकल्स थे उनको हिग्स बोसॉन बोलते हैं. So it means that it has been theorized that any particle that interacted with these Higgs boson, they got mass, and those particles that were left out of the Higgs field remained massless. मतलब अगर इनसे कोई और पार्टिकल इंटरेक्ट होगा तो वहाँ पे मास हो जाएगा, और जो नहीं इंटरेक्ट होगा, जो हिग्स फील्ड के बाहर रह जाएगा, अगर इधर इधर इंटरेक्ट हो गया तो इनमें मास हो जाएगा, अगर नहीं हुआ तो ये मासलेस रह जाएंगे. Then Higgs boson have the capability to grant mass, like I said. So primary condition for existence of matter, they were termed as God particles. So the Big Bang theory is basically the leading expansion about how the universe began. It talks about universe as we know it, starting with a small singularity, then come into force. So Big Bang was How the universe began. Now, recently, scientists observed that Higgs boson decaying to fundamental particle known as bottom quark. Now, the next is cosmic inflation. So, cosmic inflation is basically a theory which was given by Alan Guth in 1981. अकॉर्डिंग टू दिस थ्योरी, मतलब इनकी थ्योरी, एलन गुथ की थ्योरी के अकॉर्डिंग, जैसे बिग बैंग हुआ, यूनिवर्स हमारा फॉर्म हुआ, उसके बाद एक ऐसा फेज़ आया जहाँ पे यूनिवर्स बहुत ही स्पीड से एक्सपेंड कर रहा था, मतलब लाइट के स्पीड से भी ज़्यादा, अकॉर्डिंग टू दिस कॉस्मिक इन्फ्लेशन बाय एलन गुथ। बिग बैंग के बाद एक ऐसा फेज़ आया जो हमारा यूनिवर्स था वो बहुत ही तेज़ स्पीड से एक्सपेंड कर रहा था, मतलब यू कैन से दैट कि लाइट की स्पीड से भी ज़्यादा इस एंड दिस इज रिस्पॉन्सिबल फॉर द पोलराइजेशन ऑफ यूनिवर्स कॉजिंग stretching and squeezing. This is stretching, and when they come toward that, it's called squeezing of the cosmic space. Now let's discuss about cosmic microwave background a bit. What is radiation, redshift, neutrinos, oscillation? So let's talk about it. तो कॉस्मिक माइक्रोवेव के बैकग्राउंड के बारे में पढ़ेंगे. व्हाट इज़ रेडिएशन? इसमें जो बिग बैंग थ्योरी हुई थी, मतलब जिससे हमारा यूनिवर्स फॉर्म हुआ था, बिगिन हुआ था, उसके बाद जो थर्मल रेडिएशन जो बच गई थी उसको कॉस्मिक माइक्रोवेव रेडिएशन बोलते हैं. लेफ्ट ओवर थर्मल रेडिएशन आफ्टर बिग बैंग. और जो प्लैंक स्पेसक्राफ्ट, आपको पता ही होगा, यूरोपियन स्पेस एजेंसी ने सक्सेसफुली प्रिपेयर कर लिए थे ऑल दी स्काई मैप ऑफ कॉस्मिक माइक्रोवेव बैकग्राउंड. सो प्लैंक मिशन बेसिकली उसने इमेजिन किया था ओल्डेस्ट लाइट इन आवर यूनिवर्स. इट्स इमेजिन द ओल्डेस्ट लाइट इन आवर यूनिवर्स, जिसको आप कॉस्मिक माइक्रोवेव बैकग्राउंड कहते हैं. दैट्स द ओल्डेस्ट लाइट. कॉस्मिक माइक्रोवेव बैकग्राउंड बेसिकली आपको एक इंसाइट प्रोवाइड करता है कि आपको यूनिवर्स के कंपोजिशन के बारे में पता चले. यूनिवर्स, टू नो द यूनिवर्स कंपोजिशन. और इस यूनिवर्स के कंपोजिशन से हम ऑब्ज़र्व कर सकते हैं कि जो हमारा यूनिवर्स है वो डार्क मैटर से बना हुआ है, डार्क एनर्जी से बना हुआ है. डार्क मैटर, डार्क एनर्जी और एक मिस्टीरियस फोर्स है जो यूनिवर्स को एक्सपेंड करते जा रहा है. और बेसिकली यू कैन से दैट ड्राइविंग द एक्सपेंशन ऑफ द यूनिवर्स, डार्क मैटर which interact with the rest of the universe only through its gravity. So cosmic microwave background से हमें यूनिवर्स के कंपोजिशन के बारे में पता चलता है. देन रेड शिफ्ट क्या है? बेसिकली एक रेड स्पेक्ट्रा होती है विब गयोर में. विब गयोर आपको पता होगा, रेनबो के 7 कलर्स, विब गयोर. सो जो इसका रेड स्पेक्ट्रा होता है वो बहुत ही लार्ज वेवलेंथ का होता है. इसकी लार्जर वेवलेंथ होती है. लार्जर वेवलेंथ की वजह से जो ये होता है, बेसिकली इसकी वजह से गैलेक्सीज आर मूविंग अवे फ्रॉम अस. So this red spectra is of a larger wavelength, like I said, under Vibgyor. This shift indicate that essentially all of the galaxies are moving away from us, whereas there is also same like blue shift. Blue shift में क्या होता है? Vibgyor में एक blue color होता है. इसकी वजह से सेम इसका जो वेवलेंथ होता है वो इसका लार्जर होता है, इसका स्मॉल होता है ब्लू का. सो इसकी वजह से जो डिस्टेंस ऑब्जेक्ट होते हैं वो हमें ऐसा लगता है कि हमारे पास आते जा रहे हैं. इट मीन्स अ रिलेटेड फिनोमेना विथ रेड शिफ्ट, एंड इट्स इंडिकेट दैट डिस्टिंक्ट ऑब्जेक्ट अपीयर टू बी कमिंग क्लोजर टू द ऑब्जर्वर. Now we will read about the next topic, that is neutrino. So they are produced by decay of radioactive element. Not elements, it's elements. So neutrinos, as you can see, that they are produced by decay of radioactive elements. And after photons, as you know, photons are light carriers. They are most abundant particle in the cosmos. So first is photons. After photons, the neutrons come, and they both are most abundant particle in the cosmos. And photons, you know, light carriers. So neutrinos, they have mass, but it exceedingly small, a tiny fraction of the mass of a proton. They have mass, but a very small portion of it. Then there are three types of neutrinos. These are called flavors. The one is electron, the other is muon, the third is tau. Now the main difference between the neutrinos and their relative is that neutrons are electrically neutrals. So these are electrically neutrals, while the electron, muon and tau, they are electrically charged. There are three types like I discussed. They are charged, but neutrons is electrically neutral. So being electrically neutral, they are difficult to detect, and as well as they do not readily interact with other form of matter. But using special equipment located in deep underground laboratories where no other cosmic particles penetrate, so their neutrons can discovered. They can be, and they have already discovered. So now the next is dark matter. Dark matter, it was in 1930 when Zwicky observed the many galaxies were moving faster than, oh, I should wrote the scientist's name. It's Zwicky. So in 1930 he observed that many galaxies were moving faster than theoretical calculations. So for example, these are galaxies, so they are moving faster as per their theoretical calculation. So this implied that there was some mysterious gravitational force which pulled towards the center of those galaxies, and these extra matter which invisible and undetected is known as dark matter. Gradually, with the passage of time, many astronomers started researching on dark matter. Then it was our nearby galaxy, that is Andromeda. Andromeda galaxy was observed to be moving faster than expected. So if galaxies move faster than expected, so it's believed that there is some invisible force, invisible and undetected matter, and that is known as dark matter. So till yet it has not been observed directly. It does not interacted with matter, and it's completely invisible to light and other form of electromagnetic radiation. So you can write here, it's what I have just said, that it's completely invisible to light. So that's why it's impossible, as well as electromagnetic radiation. So if it's invisible, then it's hard to detect it. Even scientists are confident it exists because of the gravitational effect it has on galaxies and galaxy cluster. So there are two school of thoughts on the existence of dark matter. Yeah, I should take time in writing two school of thoughts which believe in existence of dark matter. First is Mikos. How you pronounce it's totally depend on you, and the other is WIMPs. So here it is a massive compact halo object, and objects, and this is a weakly interacting, it swims weakly interacting massive particles. So they are made up of barons, that is proton and neutrons. You can write proton plus neutron, while these are consist of exotic particles and they are non-baryonic. So dark matter respond to of the fundamental forces. They respond to two forces. They are weak nuclear force and gravitational force. Now we done with dark matter. Now study about dark energy. So dark energy, you can say that roughly 68% of the universe is dark energy. How much? 68% of the universe. And it is a property of space, so does not get diluted as space expands. So if more space come into existence, so more of this energies appear. It means that it does not get diluted if space get expand or more space is there, so more dark energy also there. While dark matter, you can say, exert a pull on the universe, dark energy has a opposite effect on it, as it evident our universe is expanding, as you know that, but dark energy has a greater abundance than the dark. If dark matter is there, dark energy is more in abundance than dark matter. Now, as you know that the law of cosmology, the total amount of mass in the universe cannot increase according to cosmology, law of you have studied also, law of cosmology. What does it says? It says that amount of mass does not increase. Amount of mass in universe that not gonna increase, because the amount of dark matter remains constant. Even dark energy, which is a property of space itself, is bound to increase. This gonna remain same, but the energy is gonna increase. So dark energy would overcome the influence of dark matter and lead to the expansion of universe. Now we will study about black holes. Now discuss about what does black hole. Holes, I have written black holes. So a black hole, you can say that, suppose it's a black hole, it is a region in space where the pulling force of gravity is so strong that light is not able to escape. So you can say that for example, this is space and this is black hole. So it is that region where pulling force of gravity is so strong. Can't imagine that light is not able to escape. So the strong gravity occurs because matter has pressed a tiny space. A black hole cannot be seen because of the strong gravity, so you cannot see it. As well as black hole gravity can sometimes be strong enough to pull off the outer gases of the star. I mean, it pull off the outer gases of the stars. I mean, that much strong. As gas spiral into the black hole, the gas heats to very high temperature and releases X-ray light in all directions. Black holes are detected by these X-rays. X-rays. I mean, our sun does not have enough mass to collapse into a black hole, but in billion of years, when the sun is at the end of its life, it will become a red giant star. I mean, nowadays, currently it will not get collapsed, but after a billion of years, it may become a red giant star. Then you can say that it has used the last of its fuel, so it will throw off its outer layer and turn into a glowing ring of gas called planetary nebula. I mean, after number of billion of years, then it will be a cooling white dwarf planet. After black hole, we will read about gravitational waves. So gravitational waves, in short, you can say that these are small ripples or disturbance, whichever fits you, you can use. Small ripple or disturbance in space-time curvature. Oh, I should write it here. Curvature. So, as I said that, and they are believed to travel across the universe at the speed of light. They travel. Speed of light, I mean, too strong. Across the universe. They were predicted to exist by Albert Einstein in 1916 as a consequence of his general theory of relativity. So, in 1916, Albert Einstein, while relating to his theory that is of relativity, he predicted these waves. Yeah, that is theory of relativity. Then massive accelerating objects such as neutrons or black holes orbiting each other disrupt space-time in such a way that waves of distorted space radiate from the source. I mean, you can say like the movement of wave away from stone thrown into the pond. For example, this is a pond and you throw a stone, it should be like this kind of. So same thing has been uh, with the case of gravitational wave also. These ripples travel at a speed of light through the universe, and along with that they carry information about their cosmic origin as well as clue to the nature of gravity. What does these ripples carry? They carry information like cosmic origin and many nature of gravity itself, then the strongest gravitational wave are produced by catastrophic events such as colliding black hole and supernova. For example, these are black hole. If they collide somewhere here, then the strongest gravitational wave produced. Or you can say that they transport energy in the form of gravitational radiation. They pass through matter without interacting with it, and these are measured by LIGO. LIGO is Laser Interferometer Gravitational Wave Observatory. So they are measured by LIGO. Now discuss the LIGO. What does LIGO here is? Like I said, LIGO is Laser Interferometry Gravitational Wave Observatory. I should write also Laser Interferometer Gravitational Waves Observatory. So LIGO observatories are funded by NSF, that is, these are the basic theoretical information, funded by NSF, that is National Science Foundation, and it were operated by MIT. So LIGO has a pair of ground-based observatory, you can ground-based, which you can found in Hanford, Washington, Livingstone, and Louisiana. So this W is Washington. So LIGO has detected the gravitational wave, till yet twice. Detected twice. What? Gravitational waves, because that is, it measured the gravitational wave. So the second time witnessing the merging of a black hole pair, and the first time was when a spatial technique used called matching filtering was adapted for gravitational wave data analysis. Now LIGO, in news like last year, LIGO has recently been able to not just detect but also produce gravitational waves too. So these point to be noted, not just detect but also produce gravitational wave, and these wave are. So we are done with this LIGO. Now we will discuss about LIGO India. In India, where the observatory has been planned to set up. So that is LIGO India. So it is planned as a collaborative project between, it gonna be a collaborative project between consortium of Indian Research Institution INR and LIGO, that which is based in USA, LIGO laboratory in USA, along with its international partner like Australia, Germany, UK. So LIGO India gonna establish a site near, you can say on the north, in a site in, not near, a site in Hingoli district of Maharashtra. Now let's know about Council of Nuclear Research, that is we discuss about, and it's European. So that is European Council for Nuclear Research. It was founded in 1952 as a provisional body. It's the world's largest nuclear and particle physics laboratory with the mandate of establishing a world-class fundamental physics research organization in Geneva. So CERN, fundamental particles matter, are made to collide together at a speed of light, giving the physicist clue about how the particles interact at such high speed. And it has a 22 member state and 4 associate member, 4 observer state and 3 observer national organizations. So Indian scientists have been part of this research. Indian scientist part of this, I'm writing very fastly, since 1960 with the support of DAE and DCT. DAE and DST, that is Department of Atomic Energy and Department of Science and Technology. So recognizing India's significant contribution, India was awarded the observer status of in 2003. India was invited to join as an associate member in 2016. So even CERN that will enhance participation of young scientists and engineer in various objects. It will also provide opportunity to Indian industry to participate directly in these project that is a nuclear research project. So that's for today. Thank you.